Welcome to my channel. In this video, we are going to solve some of the important question asked in the question paper, the 2021 TRB Polytechnic exam. Okay, so in that especially, we are going to discuss about the questions from the circuit analysis and circuit theory. Okay, so the first question, so from the subject, there are 10 1-mark questions they asked and the 4 2-mark question we are going to see. So the first question, superposition theorem is only valid for which circuit? Linear, non-linear, both linear and non-linear circuit, neither of two linear, non-linear circuit. So superposition theorem is valid for linear circuit. Okay, so this question is a very important and repeated question in TRB exam. Okay, then the next question, transfer impedance. Transfer impedance in two-port network is defined as the ratio of voltage transform at one port to voltage transform at another port, that is V2 of S divided by V1 of S. Current transform at one port to current transform at another port, current transform at one port to voltage transform at another port, voltage transform at one port to current transform at another port. So you see impedance, so simply the impedance is that is nothing but, so you know the general definition, impedance is nothing but it's a ratio of voltage by current. Okay, so that's why transfer impedance, it's a ratio of voltage in one port divided by current in the another port. So that's why D is the correct option. Voltage transform at one port to current transform at another port. This is the correct thing. The next question, the Thevenin's impedance is found as dash. Okay, so the Thevenin's impedance in Thevenin's theorem, we will calculate the Thevenin's impedance, the total impedance of that particular circuit. So during the Thevenin's impedance calculation, so what we have to follow? The first option is given by short circuiting the given two terminal. Okay, so while calculating the Thevenin's impedance, we not at all short circuiting the given two terminal. Then the Thevenin's impedance is found as between any two terminal. No, by connecting load across the given two terminal, it is also wrong. Between the given two terminal open. Okay, while calculating the Thevenin's impedance, we have to open circuit the given particular terminal. Okay, so that is a while calculating this Thevenin's impedance, the two terminal we must be open circuit. After that, across this open circuited thing, we have to calculate the total impedance of that circuit. That is said to be Thevenin's impedance. So D is the correct option. The next question, an inductor in S domain consists of dash. Okay, so while the inductor is represented in Laplace domain, S domain means Laplace domain, it consists of dash. Current source in series with inductor, voltage source in parallel with inductor, voltage source in series with inductor, all current source series with an inductor, voltage source in parallel with inductor, and voltage source in series with an inductor. When the inductor is represented in S domain, so the correct option is voltage source in series with an inductor. Okay, so C is the correct option. Then the next question, the initial value of 20 minus omega t minus e power 15t is dash. Okay, so this is one function. So for this function, we have to find out the initial value. So initial value is nothing but whenever the time, okay, that is the value of this function at a time t equal to 0. Okay, t equal to 0. What is the value of this function? That is the initial value of this particular function. Similarly, final value means at a time t equal to infinity, what is the value? That is the value of final value. Okay, so in order to calculate the initial value, we have to substitute t equal to 0 in the given expression. Okay, so here in our expression, there are in two places the t is available, omega t e power 15t. So you just substitute, instead of t, you just substitute 0. So 20 minus this 0 minus e power 0. So you know e power 0 value is 1. Okay, so finally, so 20 minus 1, 19 is the correct option. So you see the 4 option is given. So C is the correct thing. Okay, similarly, the final value, if they are asking means you just substitute in the place of t, you just substitute infinity. Okay, whenever the time t equal to infinity, what is the value of this function? That is the final value. Okay, Similarly, initial value means the value of the given function at a time t equal to 0 is the initial value. Then the next question, the Norton's equivalent current ISC of the circuit is dash. This is the given circuit. Okay, so in this we have to find out the Norton's equivalent current across this terminal A and B. Okay, so ISC, what is ISC means? Short circuited current. We have to short circuit this two terminal A and B, and in this point what is the current flowing we have to find out. Okay, that is a Norton's equivalent current. So here the four option is given 5 by 2, 2 by 5, 4 by 5, 5 by 4. Okay. So now we are going to solve this problem. So first one, in order to find out the current ISC, so first we have to short circuit that two terminal A and B. Okay. So you see the point A and B, you just short circuit, and across this short circuited path, we have to find this current ISC. Okay. So while short circuiting, so here you see the circuit. So we can solve this circuit in different method. Okay, so just by writing the KVL equation, and we will solve. Okay, so here we are going to use the mesh analysis. Okay, in a simplest way. So you see here there are two meshes are there. This is the mesh 1, mesh 2. Okay, so already we studied. You're familiar with the mesh analysis and nodal analysis. So here there are two meshes are there. This is the mesh 1. This is the mesh 2. So let us consider current flowing in the mesh 1 is I1, current flowing in the second mesh is ISC. Okay, since we have to find out this current ISC. So we have to write the two KVL equation for each mesh, okay, each loop. So we may write the KVL equation, and we can convert that KVL equation into this matrix and we can solve, or otherwise directly by inspection method I am constructing this matrix. So you know the inspection method. The inspection method is if the circuit consists of two meshes means there are 2 by 2 resistance matrix. The current value in the particular mesh which is equal to the voltage rise across the each mesh. Okay. So here you see R11, R12, R21, 22. What is R11 means? R11 is the total resistance in first loop. So you see what is the total resistance in first loop? This is the first loop. So the 3 ohm resistor, 2 ohm resistor is there. So 3 plus 2, 5. Okay. Then R12. R12 means the common resistance between first loop and second loop. So you see what is the common resistance between first loop and second loop? This is the 2 ohm resistor. Okay. While writing this common resistance, we have to put one minus sign. So minus 2. Okay. Similarly, R21. R12, R21 value is both are same only. R21 means the common resistance between second and 1, which is also equal to the common resistance between 1 and 2. Okay, so that's why this value is also minus 2. And R22. What is R22? R22 is the total resistance in second loop. So in second loop, the two resistances available. One is 2 ohm, another one is 4 by 5 ohm. So you just add 2 plus 4 by 5. So the answer for 2 plus 4 by 5 is 14 by 5. Okay. Then this is the current flowing in the first loop. This is the current flowing in the second loop. In second loop, we are considering that current as a ISC. Okay, which is equal to V1, V2. V1 means the total voltage rise in first loop. So you see what is the total voltage rise in first loop? 2 volt. Okay. V2 is the total voltage in second loop. So in second loop, any voltage rise is there? No. Okay. So no external supply is given. Only the resistor is there. So the V2 value is 0. Okay. So after constructing this matrix, so you just find the determinant of this 2 by 2 matrix, that is the del. So del equal to 5 minus 2 minus 2, 14 by 5. So you just calculate the determinant value. You just multiply 5 into 14 by 5 minus of, you multiply these two values. So minus of minus 2 into minus 2. So that is 4. Okay. So the 14 minus 4, 10. So the determinant value is 10. Okay. And the next one, what is our aim? Our aim is to find out this ISC. Correct. So in order to find out ISC, we have to calculate del ISC. So what is del ISC means? You just replace the second column of this determinant by this constant value. Okay. If we want to find out I1 means, you just replace this first column 5 minus 2 by this constant value. If you want to find out the second variable ISC, you just replace the second column by this constant value. So del ISC equal to 5 minus 2. You just replace here 2 and 0. So if you are calculating the determinant of this 2 by 2 matrix, 5 into 0, 0, minus of minus 2 into 2, minus 4, so 4. Okay. So del ISC, del is calculated. So therefore, the short circuit current ISC equal to del ISC divided by del. So 4 divided by del 10. So 2 divided by 5. Okay. So the option you see. So there are 4 options given. So 2 by 5. Okay. The first option is, so you see the 4 option. 5 by 2, 2 by 5, 4 by 5 and 5 by 4. So 2 by 5 is the correct option. Okay, this is the Norton's equivalent current. Then the next question, when two-port networks are connected in series and represented as single two-port network, the parameters of the network are obtained by adding the individual dash. Okay. So already we discussed this question in that is parameter topics. So you know the two-port network, we can represent two-port network in different parameters using Z parameter, Y parameter, H parameter and ABCD parameter. If the two-port networks are connected in series means, okay, connected in series means, then if this two-port network is replaced by one single two-port network means, so what is the overall parameter of that particular network? That is the question. If two-port networks are connected in series means, we can add the Z parameter matrix. Okay. So the Z parameter of the first network and second network, this is Z1, Z2 means if you are adding the two impedance parameter, we can get the overall impedance parameter of that overall matrix. Okay. Similarly, if the two-port networks are connected in cascade means, okay, connected in cascade means we can add the Y parameter matrix. The following parameters are also called short circuit parameter. Which parameter? Here is that Y, H, Z parameter. So which parameters are called as short circuit parameter? So the Y parameter is called as a short circuit parameter. Okay, why it is called as a short circuit means, while calculating Y11, Y12, Y21, Y22, we have to short circuit either input port or output port. Okay, that's why the admittance parameter, Y parameter means admittance parameter. Y means admittance, Z means impedance. So the admittance parameter is otherwise called it as a short circuit parameter. Okay. So similarly, these are all the different way. Okay, you can ask the question. The Z parameter. What about Z parameter? Z parameters are also called it as a open circuit parameter. Okay. Since Z means impedance, impedance parameter is also called it as a open circuit parameter. While calculating impedance parameter, either we have to open circuit the input port or output port. That's why the Z parameter is called as a open circuit parameter. Y parameter, you know, short circuit parameter. Okay, H parameters are called as a hybrid parameter. Okay, hybrid. And ABCD parameters are called as a transmission parameter. Okay. Since this ABCD parameter is useful in order to analyze the transmission line, that's why the ABCD parameter is called as a transmission parameter. These are all the other names of the remaining parameter. Okay. Then the next question, a circuit consisting of two resistors R1 and R2 in parallel. The total current passing through the circuit is IT. What is the current flowing through R1 resistor? Okay, so you see there are two resistors R1 and R2 connected in parallel. Okay, this is the resistance R1, this is the resistance R2. The total current, okay, flowing through this two networks IT means, here the question is current passing through the resistor R1. So the if we want to find the current passing through this resistance R1, you know, in parallel network the current is divided. Okay, so some of the current is flowing through this first resistor, the remaining current will flow through the resistor R2. Okay, so in order to solve this, we can use the current division law. So according to current division law, if you want to find current flowing through the particular port, so the current I1 is calculated by, which is nothing but total current. What is the total current? IT. The total current multiplied with opposite resistance. What is the opposite resistance? R2. Okay, R2 divided by addition of this two resistance. So R1 plus R2. So this is the current flowing through the resistor R1. So here you see B is not a correct thing. C is the correct option. Okay, so here C is the correct option. I total R2 divided by R1 plus R2. If you want to find current flowing through R2 means total current multiplied with opposite resistance R1 divided by R1 plus R2. A is the correct option if current flowing through R2 is the question. Then the next one, the transfer function of multiple independent sources can be easily obtained by dash. Okay, the transfer function of multiple independent sources. If one circuit consists of multiple independent sources, the transfer function is easily calculated by the theorem, superposition theorem. Okay, so the superposition theorem is mainly used for the circuit consisting of multiple sources. Okay. These are all the 1 mark questions, and the next we are going to solve the 2 mark question asked in 2021 paper. So you see the first question, the value of Vx, Vy, Vz as shown in figure. Okay, so this is the circuit given, this is the some resistance value. So voltage across this one is 8 volt, voltage across this component is Vx, this is Vy, Vz. Voltage across this component is 2 volt, 1 volt, 2 volt is given. So the question is we have to find out Vx, Vy and Vz. Okay, so simply we will solve using the KVL. Okay, so here there are 3 meshes are there. So you just apply KVL to each mesh. So you see this is the first mesh. Okay, first closed path. You just apply KVL to this path. So what is KVL? Okay, the KVL is nothing but in any closed path, sum of voltage rise. Okay, sum of voltage rise is equal to sum of voltage drop. Okay, so voltage rise means when we are looking here, you see if you are measuring this voltage minus to plus. Okay, minus means lower potential, plus means higher potential. So while lower potential to higher potential, we are considering this is the voltage rise. Okay, then here you see plus to minus. So higher potential to lower potential, that is called it as a voltage drop. So in any closed path, sum of voltage rise is equal to sum of voltage drop. Okay, so if you are applying KVL to loop 1, okay, so if you are applying KVL to loop 1, you see minus to plus, it's a voltage rise 8 equal to Vx. Vx is a voltage drop. Similarly here plus to minus, this is also voltage drop 2. So 8 equal to Vx plus 2. So from that Vx equal to 8 minus to 6 volt. Okay. Similarly, you just apply KVL to this second loop. Okay. So for the second loop, so if you are starting here, okay, minus to plus voltage rise. So 2 equal to this Vy plus to minus voltage drop. This is also plus to minus voltage drop. So 2 equal to Vy plus 1. So from that Vy equal to 2 minus 1, 1 volt. Okay. Similarly, you just apply KVL to loop 3. Okay, loop 3, you just apply KVL to loop 3. So for this loop 3, so you see 1 volt is a voltage rise, Vx is a voltage drop, 2 is a voltage drop. So 1 equal to Vz plus 2. So from that Vz is equal to minus 1. So the value of Vx, Vy, Vz is 6, 1, minus 1. So you see the option. So here the option is not given correctly. Okay, so this is the grace mark question. So the correct answer is 6, 1, minus 1 volt. Okay, so this is the grace mark question. So if any answer it means you will get the 2 marks. Okay, so 6, 1, minus 1 is the correct option. Then the next question, for the network shown in figure, the admittance parameters are Y11 is 8 mho, Y12 is minus 6 mho, Y22 is 6 mho. the value of YA, YB, YC will be dash. Okay. So if for one two-port network, the admittance parameter is given. Okay. So there are 4 admittance parameter, Y11, Y12, Y21, Y22 is given. So what is the corresponding pi network value? YA, YB, YC. Okay. So already we discussed this topic in circuit analysis topic. If you want to learn that topic means, I will give link for that playlist in the description box. You can refer it. Okay. So the relation between the admittance parameter and YA, YB, YC is, so this is the relation. The YA value is calculated by adding Y11 and Y12. YB value is calculated by adding Y22 and Y12. YC value is calculated by minus Y12 or minus Y21. Okay, so here you see, so the Y1 is YA is calculated by Y11 plus Y12. What is Y11? 8. What is Y12? Minus 6. So 8 minus 6. So the answer is 2. Similarly, YB. YB equal to Y22 plus Y12. So 6 minus 6, 0. And YC equal to minus of Y12. So Y12 is here minus 6. So minus of minus 6 plus 6. Okay. So the answer 2, 0, 6. So you see this is the correct option. 2, 0, 6 is the correct option. Okay. So this relation you just remember it. So these are all the some of the questions asked in TRB 2021 exam. So already I posted some of the videos related with this subject circuit analysis for the TRB preparation. Okay, so thanks for watching my channel and please subscribe my channel for more videos. Okay, so we will meet in the next video with one more thing. Thank you.